Now that we've seen how to compute double integrals, let's talk about some applications. First of all, it's good to have a general idea of what it means to take the double integral of a function over some region D. Well, roughly speaking, what this means is it means you're going to split D into tiny little pieces. Right, little squares or maybe little polar rectangles. And then what you do is you take the area of each piece times f of some point in that piece. And then you're going to add all of those up. And so, for example, that means that the units of the double integral are units of area times the units of f. So, for example, the simplest double integral is just the double integral of the constant function 1. So this splits your region D up into tiny little pieces. For each piece, it takes the area of that piece and multiplies by 1, and then adds up all of those little areas. So in fact, this just gets you the area of the region. Or for another example, suppose you have a density function of a thin plate. Maybe it's given by delta of xy. So the units here might be something like, say, kilograms per meter squared, or in general, units of mass per area. Well, in that case, if you do the double integral of the density function over that thin plate, well, you split the region up into a bunch of very small pieces. You take the area of each piece, and you multiply by the density of a point in that piece. And in this case, the density times area will give you a mass of that small piece. So you end up getting the mass of this thin plate D. And this works, in fact, for any kind of density, not just mass density, but you could have a charge density, for example. Anything that has units of something per area, you can kind of think of as a density function, and then integrating it gives you how much of that thing, how much mass or charge there is on that thin plate. Okay, what are some other examples? Well, one very general example is to find the average value of a two-variable function on some region D. Now, of course, if you want the average value of a function on just a finite number of inputs, you just find all of the outputs and then average them in the usual way. But in this case, we have to do something a little bit different because D has infinitely many inputs. So it turns out that the right thing to do is to take 1 divided by the area of D times the double integral of f over D. So what you're doing is splitting D into a bunch of small pieces, and for each piece multiplying that little bit of area by the value of f, but then at the end dividing by the whole area of the region, and so the units of area cancel out and you end up with just units of f. Okay, one nice example of this is for what we call the centroid of a region. So the centroid of a region is a point, which we often call x bar, y bar, where x bar is just the average value of x. So it's 1 divided by the area of the double integral of x on that region. And then, of course, y bar is the same thing, but with y. So these give you something like the, we call it the centroid. It's sort of like the center of the region. For some simple geometric examples, you can kind of see this just kind of looking at it a little bit. Let's say you have a region that looks like a sort of an inverted triangle here. The average x value of a region like this is going to be 0. It'll be somewhere here on the y-axis. And the average y value, well, what happens is there are more points up high than there are down low. So the centroid ought to be somewhere kind of here-ish. But for most regions, you don't have much of an idea of where the centroid is unless you actually do these calculations. And finally, here's one more example that is like a centroid. The, say, center of mass of a region. We also often denote that as x bar, y bar. So you have to use your context to know what x bar and y bar mean. So just to emphasize, these are not the same as they were before. But it's a very similar idea. In this case, what you want is 1 divided by the mass of the region times the double integral of x times the density function. And then y bar is 1 over the mass times the double integral of y times the density function. And I should remind you that the mass in both cases is just the double integral of the density function itself. So in principle, finding the center of mass of a region might involve doing 3 double integrals. 1 to find the mass, and then 1 to find x bar, and 1 to find y bar. So these are some of the applications of double integrals, and we're going to next look at a couple examples of finding things like mass and centroid and center of mass.